today. This is Unit 2, Lesson 1. Welcome to our second unit. We're still staying in space, but we're going to be continuing with gravity and going a little bit more in depth and talking about orbit and things like that in particular. So basically going to work our way through the rest of Chapter 5 in Hewitt. So look for tasks to complete for U2L1, either under assignments in Science 2 or on the home page in the weekly calendar table. You can find it there. As usual, I'm going to start off with a quick little breakout room thing. Our silly question today is in the chat right now. Question is, if you could be in any movie, what would it be and what character would you play? Have you guys answered this question yet? You have not answered this yet. Okay. So again, if you could be in any movie, what would it be and what character would you play? Now, a couple clarifying things. If you want to do a TV show, I'm okay with that. Or if it's an animated movie or something like that, that's fine. Also, don't be afraid if it's a character that like dies or it's a tragedy, still okay, you might want to still emulate that character. Just think more about them or their experiences or what they stand for. So again, I'm going to give you about 20 seconds to think about it. And then I'm going to open up breakout rooms. Okay, breakout rooms are open. We'll come back together in 2 minutes. .5% of your grade, they're the same value as homework. It's labs and activities that are actually a little more valuable, and we're going to be doing a lab and activity today. So without further ado then, let's move on and get started on Unit 2 and learn a little bit more about gravity. I want to kind of refresh your minds with what we've learned a little bit from Chapter 5. We've read 5.1 through 5.4 already. To do this, I have an ed puzzle that I would like you to work on. So on the tasks to complete list, this is step number 4. The Science2B Vsauce Mass and Gravity Ed Puzzle. How many of you have heard of Vsauce or watched Vsauce videos before? Anybody? A few? Yeah, they're not as popular as like Hank Green and Crash Course, but they're kind of similar. He's very enthusiastic. So the Ed Puzzle, if I remember correctly, is just short of 8 minutes long. And there's probably about 4 questions, or there's more than that. I think there's maybe 8 questions. So I'm going to time for 12 minutes, but I can see your progress. So as I see people finishing and submitting, once we're sort of all done, I'll call us back together if that happens before 12 minutes is up. But otherwise, let me know if you need help. I'm here listening. But 12 minutes to work on that ed puzzle. Go for it. All right, I hope that was somewhat informative or a little bit of review. All right, I can break down the individual questions here, so let's do that, see how we did. First question, what is the difference between mass and weight? This is a very important distinction, and it looks like pretty much all of you got that it is mass is a measure of how much matter an object has, right? So think about it's a measure of your mass is just all the matter that makes up you. Weight depends on gravity, right? Weight is how much you are weighing upon the planet we're on, right? Weight is determined by Earth's gravity. If you were to stand on the moon, you would have a different amount of weight, even though your mass was the same, because the moon's gravity is a little bit different in its attraction, right? And this kind of then is an important point for the next question, which is why can we say that an astronaut is weightless but not massless? And it looks like most of you got this, but can anyone just give me a quick shout out if an astronaut was massless, what happened to that astronaut?
They disappeared because there was no longer any matter within them.
Very good, right? You would have made them vanish. So that's an important distinction, right? Again, weight can change because it depends upon gravity, and gravity can alter depending on what planet you're on or distance from the source of mass. But yes, mass is usually not changing. You can change your mass, obviously, like if you were to lose a limb or something like that, then technically your mass changed because now there's less matter making up you. Hopefully something like that never happens. But yes, that's important to distinguish is that we say astronauts are weightless, not massless. It looks like most of you got that. All right, this to me is kind of the mind blower of the video. Weight is mutual, and it's all about perspective here. So I think he does a good job of demonstrating this with the scale the spring scale that he was using. But if you weigh 200 pounds on Earth, means that Earth is drawing you towards it with that amount of weight force, right? That also means, though, that you're pulling Earth up to your feet. And so the Earth is also weighing 200 pounds on you, which, again, what helped me was the whole bathroom scale thing he did and how he flipped it over. But I think that's kind of the mind-blowing thing here. Seems kind of weird to think about, but that's what happens. Even something like a pencil, which he was showing that he dropped, has a little bit of a gravitational effect, a gravitational pull on the entire planet that we're on, which is pretty crazy. So what would happen if the ISS were to suddenly stop, if it lost all of its tangential velocity? Very good. All of you get that it would come crashing down to Earth, just like an apple falling from a tree. They experience maybe 10% less gravity out in space than we do here within Earth's atmosphere, which is not a huge difference. So again, the reason why they're floating around is because they are falling around our planet. They have high tangential velocity. And again, something we're going to be exploring more in this unit when we get into orbit in detail. So why do astronauts have no apparent weight? It is all of those things. So think about that for a second, right? That would be a really weird experience. Like when an astronaut is on the space shuttle, when they go to bed, they don't feel their head like hit the pillow, right? In fact, I don't know if anyone's watched this. Does anyone know how astronauts sleep when they're in space? Does anyone know what they do?
They sleep on a wall up and down.
Yep, and they have to zip themselves into like a little sleeping bag, or else they'll go floating around the station while they're asleep, which is pretty weird to think. So they are in free fall. It's the exact same thing that would happen if you were in an airplane here in our atmosphere that went into a dive, because everything around you appears to be floating because they're all falling together. That's what's going on with astronauts. They're not experiencing zero gravity. It's a big misconception. They experience pretty much almost as much gravity as you do. It's just that they are falling around the planet constantly. In fact, that is how they train astronauts. They'll take them up into an airplane and they'll have the airplane go into a dive so that they get a very brief moment of experiencing that sort of zero gravity before they then have to climb back up and do it again. They call it the vomit comet because people often get sick. We're going to explore more of that in our next lesson. So it looks like most of you took the key points away from the video. Any other questions or comments on that and what Vsauce was talking about? It's part of a much longer video too. If you want to watch it, he goes into a lot more detail about orbit and things like that, which we'll be doing later, but you're welcome to check out the rest of that video. Okay, so now I want to do a little bit of activity, but before we get started on that though, a short little lesson. So we've been talking all about gravity, but how do we sense gravity, right? He talks about weight and how we're weighing upon things, and you're very aware of that, right? We can feel it in our feet when you've been standing too long. You know when you've been flipped upside down or when you've turned left and turned right in a car. So what's the biology behind that? Does anyone know what organ in your body senses your motion and your body position? What's the key organ? It's not what you would think. Everyone see what I have here? What's this? Someone shout it out.
An ear.
Your inner ear is what gives you your sense of balance and direction. And so I'm going to give you just a short little video about this. So yeah, this is a model of the human ear. I'll take the bone off the front here. Your ear has three parts to it in the internal structure. You have your outer ear, which is what you see, and the canal going in. You have your middle ear, which is where your, does anyone know what this is called? It's named after an instrument.
Eardrum.
Mm-hmm. That's where sound is initially transmitted. Makes that vibrate. Your inner ear is all these little tiny bones right here. These are actually the smallest bones in your body, and they literally hammer upon a little window that's part of this, which is your inner ear structure. This is called your cochlea, which is kind of where sound vibrates through this little curved ring here, and your body interprets there's a fluid in there that vibrates, and this is your auditory nerve that then goes into your brain. Your brain interprets the vibrations as sound. But I don't want to focus on that. We're not talking about hearing. We're talking about, everyone see these rings here? These are called the semicircular canals. And this is what allows you, this is what gives you a sense of direction, specifically with your head movement, right? When you nod your head, shake your head, you're aware of that motion because of these. And I think this is so cool because does everyone notice the orientation? Does everyone see how you kind of have like a y-axis, an x-axis, and a z-axis? You get your 3 ranges of motion from these 3 little loops. And the way it works is these are full of a fluid, and there's little tiny hairs in these sacs on each end. And as you move your head back and forth, this fluid moves a little bit with your head, but a little bit more slowly. And so the little hairs are in the fluid and they bend as the fluid is moving. And your brain interprets that as like we moved left, we moved right. Or again, we're upside down. It can sense that kind of motion too. And there's some more complicated stuff happening on the inside. It's called your vestibular structure. But I think it's just really fascinating, and you've got 2 sets of that. Now, I want to emphasize, though, your sense of direction and balance is not this alone. This is definitely one of the main things, but your vision as well, right? We can see if we're upside down or right side up or something like that. That's an important thing. And also, all of your joints, believe it or not, have usually some kind of nerve in there that is telling your brain whether it's bent or not, right? Like even when you're asleep in a dark room, you know if your legs are bent or not bent, right? Your body's aware of that, your body position, because of those senses. What I find really interesting too is if there's ever a discrepancy between the messaging, things really go haywire. So imagine you're in a car driving, right? Your ears can sense that momentum, right? Your ear is saying, hey, we're moving forward, we're stopping, we're slowing down. But you're sitting there staring at your phone. So your eyes are saying, no, we're not moving. We're just sitting here staring at our phone. And when you have that discrepancy, does anyone know? Some people are really prone to this. How does that make you feel if there's like a really big discrepancy between your eyes and your ears? Maybe some people, yeah, nauseous, car sickness. And it also happens in airplanes and on boats and stuff too. Seasickness as well is a result of that. It's just your brain's messaging from the eyes and the ears isn't lining up, and it just makes everything, your brain's like, what the heck? And you get really, you have a stress response, you sweat, you feel really sick and nauseous. I find that kind of interesting. So we're going to play with that a little bit today, see how well your balance is and how you can play around a little bit with your sense of balance and orientation. So the activity we're going to do is on the tasks to complete list. This is step number 6, sensing gravity. I'd like you to click on that assignment right there, which is Sensing Gravity Balancing Challenge Flipgrid. What you're going to need is 3 objects that you can pick up and move with your feet, specifically your toes. So if you've got dog toys or like a small hand towel, or you can put like cereal in a bag or candy in a Ziploc bag, something you can grab with your toes. You need 2 containers, like 2 big pots or a laundry basket or something like that. You're going to put those 2 containers next to each other on the ground. You're going to stand next to them and stand on one foot, and with the other foot, you're going to grab and move those objects from one container into the other container. Very simple. I have instructions on how to do this in a demonstration video as part of the assignment and on the Flipgrid, but just to give you a quick rundown here, you're going to do 4 rounds, right? In the first round, you're going to have your eyes open and your arms stretched out to help you balance. In the second round, keep your arms out, but I want you to close your eyes and just move those same 3 objects just from one container to the other. That's all you're doing. Third round, you're going to open your eyes, but hold your hands behind your back. And the fourth round, you're going to close your eyes and hold your hands behind your back. And so you'll film yourself doing these things on Flipgrid. At the very end, I'd like you to reflect on which was the most challenging and why you think that was. So I'll give us about 15 minutes to work on this. I think that works out. Yeah, we'll have a little less than 15 minutes. Let's plan for about 13 minutes to try this. Again, the demonstration video is on the assignment and on the Flipgrid. I'll be here if you need help with it. Go for it. How was that for everybody? Nobody fell into a cactus or a glass door or down some stairs, hopefully? No? I'm always worried about that. So be honest, what was harder, with your eyes open or eyes closed? Hoping this is kind of obvious.
Close.
Yeah, it's amazing once you have that information, your body's suddenly like, whoa, what's going on? What about what was harder, arms behind your back or arms out? Any thoughts?
Arms behind your back.
Yeah, that tends to be the case because you are narrowing what's called your center of gravity over your base. However, I have had some students who reflect like actually like I felt a little more stable with my hands behind my back, whereas like when they were out, felt more wobbly. So kind of go either way, I think. Um, I'll check out those Flipgrids when I can. Your only homework is to make sure you complete that. So make sure you post a Flipgrid for that. If Flipgrid isn't working for you, just email me the video. Otherwise, you're going to continue reading in chapter 5. You're going to be reading Hewitt chapter 5.5 through 5.6. Continuing, I know we read the first part a little while ago, so it might help you review that too. The usual deal, submit a photo of your notes and complete a reading quiz as part of that, and we'll review it the next time we meet. Questions on the homework? That's it for me, kids. Thank you very much. Have a good day.
Thank you.
Thank you.